So thank you very much, Mr. Bharat, and dear ladies and gentlemen. Thank you very much giving for me such a wonderful opportunities. And also I like the very motivated opening speech by him. Very, very interesting. So I'd like to talk about current general situation of the entire machine tool industry, or manufacturing, as you know, making the materials, formings or subtractive or additive type of the making the shape and the assembly and also quality check and the installations and the life cycles and so on. We are mainly focusing for the how to make the real parts in a very smart and nice manner. So my speech is not so much about assembly, but going to give the people to share the current situation of the entire machining industries all over the world. So in 2028, the DMG MORI Moriseki part, Japanese company, going to celebrate 80th year of the after the establishment. And my German part is already 150 years old, so one of the oldest machine tool builder, still listed in Frankfurt Exchange, and we are listed in the Tokyo Exchange. But I'm not talking about we are historical company. Since we have been in the business so long that we know where the customer or machine shop is existing in the world. About 100,000 machine shops or Rolls-Royce or Boeing big shops existing in the world. Not all of them, 100,000 is our customer. And in the world, we know that about 300,000 machine shops are existing. So that means 200,000 machine shops are not our customer. Maybe some reason they don't like me, or they prefer the American, if it is American customer, they prefer some of the domestic things, or many reasons. But anyhow, we know there are people. And from us, 300,000 machines are working all over the world. It is very important. We Japanese say, or even Germans say, that manufacturing is a core competence for the Japanese or Germans. Or in Japanese word, Kaizen is a very popular word, as well as tofu or those kind of things. But well, the monozukuri is meaning of the manufacturing in the Japanese word. But I don't like those kind of things, because any complicated machines, big machines or systems and so on, if you give us 2 years, sometimes we delay to 2.5 years, but anyhow, the manufacturing takes only 2-3 years, but maximum. Most of the machines are shipped after receiving the order 6 months. But after the installation, most of the customers using more than 20 years. Global average depreciation machine tools is about 10 years, and they use it about 20 years, sometimes 30 years, 40 years, something like that. So in order to cover the global footprint of the customer, of course, the Japanese company, we have a very large company factory in Germany, very close to Munich, and in the center of the Bavarian mountains, very close to Neuschwanstein, Waldrich castles. Also, we have a factory in Iga, in Mie Prefecture in Japan. Very famous place for ninja, was about 400 years ago in these regions. Also, Nara is the eldest capital city in Japan, and we have a complete automation factories over there. We have some small factory in Italy, 2 factories, and 1 big factories, including casting foundries in Poland. In the United States, we have Davis factory. Maybe, I truly believe that the U.S. manufacturing is coming back, so maybe we need to make 1 more factories. Mark Moore recommended me to make it in a nearby Illinois state, just in between Hoffman State and Rockford or something like that. But huge potential that we are going to make one more factories in the United States. We have 2 factories in China, and there used to be, we have one factory in Russia, but it was occupied by the Mr. Putin about 2 years ago. And we just got the insurance from the German government to cover the loss of that. But anyhow, that means big countries like the United States, China, or even Russia, no more. But we have to be an insider, and we have to make something good in this domestic place. As for the tariff issues, 15%, used to be Japanese machine to 0 tariffs, and the German machines are 4%. 15% sounds very tough for us and for the customer, but the reality is that if we are selling the 1 million set of the machine tools to one particular customer, the machine imported value from the Germany or Japan is something like $600,000 US dollars. And we make all the engineering and the software and also cutting tools and the work holdings and all the peripherals procured and manufactured in the United States. So even though 15% tariffs, the real cost is only 8 to maximum 9% increase, and we can share or ask customer to pay or going to give additional warranties for something like that. So this is very important. Look back about 20 years ago, our companies, at that time I think it's big, but now we are becoming, for the as a company, we are growing from 1 billion US dollars to 3.5 billion US dollars. You can see that always general machinery is very important, but for like space, about 20 years ago, we say aerospace, but now we are separating aircraft and space. 20 years ago, space was 0. And then that means a lot of the big rockets and motors and satellites and those kind of things. Now it's becoming 7%, thanks to SpaceX, Blue Origin, Americans and the European space things. And aircraft is also very, very important. And the dial mold are always keeping very important sector. And the precision and the semiconductor is also growing. And then, about 20 years ago, not only for us, entire machine industry is depending on automotives or conventional combustion engine type of the cars and the motorcycles, more than 30%. In our case, 34%. Now it is becoming only, as a percentage-wise, 14%, but 34% of the 1 billion is 340 million US dollars. And then 14% of the 3.5 billion is at the 500 million US dollars. So we are still growing, but the portion dependency on car industries is as a percentage-wise, it's reduced. Medical is only 2% about 20 years ago, but now it's becoming 8%. Aging societies give us a lot of demand for making the joint. And also US leading companies such as JJ and so on are the leading role for making those kind of things all over the world. For instance, that their Ireland factory is now becoming fully occupied. So they are now making a new factory in Costa Rica. The Costa Rica government is inviting the medical type of things. So we just make 3 people's company in Costa Rica to make an installation and service over there. Very nice place for the surfing because facing to a Pacific and Atlantic oceans. So this is very, very important. Why we can do this? Still, some of the machine tool builders struggling, only making the machines only for the automotive combustion engines, and too much depending on Asian market, especially for China. So the order is 0 over there. So it is very important to make a very flexible and then software-driven machines. That means that very smooth and robust 5-axis with turning functions or mill-turn technologies. And if we can make small to medium, about 10 different sizes of the 5-axis or mill-turn machines, we just changing the peripheral and the software and the cutting tools. We can machine almost any kind of the parts existing in the world. As for the by the area, this is a Japanese or German company's point of view. Of course, about 20 years ago, we are exporting more than 50% to outside, but 50% Japanese market. But now, becoming very, very important market, US, but still Japan and Germany, because we are German-Japanese areas. Look at this. Our exposure in China and Asia is not so big compared to other machine tool builders. My strategy is that we don't have to be a fast visitor in emerging countries. And we are selling the complete same machines all over the world. So a lot of Chinese customers want to buy the machine from us. But we don't sell, and also that I can't get a permission from the US government and the Japanese government or German government to sell that particular customer. For instance, about just only 5 years ago, Japanese government cannot give us a license to sell our products, advanced 5-axis machines to a Chinese aircraft manufacturer. But the German government allow our German part to sell some civil purpose aircraft company to use our machines. But since the last 3 years, it is strictly prohibited. So we are losing a lot of market in Chinese customers. Sorry to some of the very loyal customers, but we cannot sell even the spare parts over there. But simultaneously, that we can get more orders from the US and the NATO related type of the business for that. Size of the customer, as Mr. Barrett mentioned, this is the key. We are doing a lot of business with top-notch big Fortune 500 or government business. But reality is that you can see that in 20 years ago and now, majority of our customers, in our case, more than 50% of the customer less than 100 people's SMEs. Including family-owned, some 500 less is over 70%. And this trend will continue. It is very important. And this is not only for the US, Japan, or Germany, advanced countries, same in France, all over the world. In order to run a machine shop or SMEs, the government give a proof or support SMEs. That means that if you buy a property, this is your property. If you buy the machines, you can depreciate 10 years. You have to have a very solid financial rules. And buying the machine tools of making the factory is easily to get over 1 million. So you have to get a very good financial banking systems. We are cutting metal, sometimes plastic, ceramics. You have to buy high-grade materials, machine the parts, and then ship. So you have to have a very good logistics system. If there is a ship only once a month or something like that, truck is coming once a week, you cannot run the machine shop. And in order to make a high-quality product, you have to have a good operator. People who don't know how to use a gauge or what is the programming and so on, this kind of people not necessary for running the machine shops. So good educations, the secure, the private asset, and the good financial system, the logistics. This is only available for developed, not advanced countries or G20 countries. Now it's a great mistake of understanding, the manufacturing should go to cheaper areas and so on. This is a great misunderstanding, especially for big capitalist or mass media type of things. The other thing is that not everybody is graduate from top-notch universities in Harvard or Stanford or type of things. And then not everybody is good for doing IoT type of things. So if you are a graduate from local high school and so on, but you have good skills for mathematics, accounting, and you know how to operate machines or welding and so on, the very best way to have a nice life, or have a house and golf clubs and some boat in the Michigan Lake, is that hiring the people, 20 people, buy our machines, hopefully, and then run a machine shop and work for the SpaceX, or Blue Origins, or Ford Motor, or Boeing. That is the very best way for the local rich people. And this is, I could see all over the world, in the United States, Japan, even in China or India, France, Germany, UK, and all over the world. My customer is those kind of customers. So it is very important to have eye-to-eye communications. We are DMG MORI, over 10,000 employees. You are a small machine shop. We don't need those kind of salespeople, service people in our organization. So we always work together with small, medium enterprise. Okay. So we are now talking about the machining transformations, MX. Next one, please. So I want to show you some image videos. Yeah. What is machining transformation? As I said, that very robust and high-speed 5-axis or mill turn, you can pack the turning and milling, the measurement and the grindings, or sometimes heat treatment into one machines. So we can eliminate 20, 30 years old special purpose machines into a very new 5-axis or mill turn technologies. You can make the gears or turbines or any kind of things. And then by doing this, the process speed becomes a little bit longer because we do everything. But that's good for automations. If you have 5 machines, process separated, you need 5 robots in front of the machines. But if you pack entire process into one machine, you need only one robot or pallet changing things. But in order to achieve that, we need a complete digital twin technologies. Otherwise, you cannot simulate or you cannot program those kind of things. Yeah. So in short, everybody talking about we have to do something DX. But DX is just a tool. Without DX or digital technologies, we cannot make anything realized. So the process integration comes first. Yeah, 20 years ago, the movement of the 5-axis or mill turns are not so flexible because the CPU power, memories, or 5G are not available. So we clearly remember about 20 years ago, if you are making a die and mold, big 5-axis machine sometimes stops. They cannot accept the huge data from the CAD system or CAM programmings. But now, machine is waiting. Give me more data. I can move more faster. Yeah, something like that. Then, automation. One of the most slavery job in the factory is just putting the raw materials into the machines and taking out. Yeah, and the old automotive way of the manufacturing, you have to do it in a takt, in a very, so that the people are very much tired after, one shift and so on. Now, we can automate, or we have to automate everything at such kind of lazy or unattractive jobs in the factories, and make the factory more attractive for any people. The most important thing is by doing this, we can minimize the net working capital, work in progress in the factory. Most of the carbon oxide, dioxide, CO2s are, in relations conjectured with the number of or quantity of raw materials. If you can minimize the work in progress, this includes the work in progress during the shipping. So if you buy everything from China or Asian countries to United States, it takes about, including the port time and the domestic transportation over there and here, 2 months at least. And you are fighting against a delivery 1 week or 1 month, but you still have a, work in progress or network capital just only laying on the ships is, 2 months. So that means network capital or work in progress is a cash. So there is a way that if we can make a proper machining transformation, we can generate more cash profit, and we can minimize the CO2. So this is what we are thinking that machining transformations. I have been working very close with Siemens. We are the largest Siemens CNC user. We're always buying about 100 million euro CNC systems, including power cabinet from Siemens. About 50 million US dollars from the FANUC, 40 millions from Heidenheim, and 30 millions from Mitsubishi Electric, and about 10 million from Beckhoff. So all 5 major CNC producers are our friend and cooperative company. And with our figures, our market share not so much growing, always globally 3 to 5% something. In the United States, really, or in Japan, really over 10%. In the European countries, is a little bit better, about average 25%. I strongly believe that there is about 5 million machine tools with some proper controls existing in the world. And half of them is, there are 2 big issues. Half of them are already 20 plus years, becoming very old. Imagine 20 years ago, no iPhone, and computer is so slow. Those kind of things still keep running the machines. Yeah, it's robust, but not good for new technologies and the preciseness and so on. And the other thing is that, accuracy type of things, but, this 5 million machine tools should be, I'm quite confident that we can integrate 5 machines into one package, speed and the flexibilities and those kind of things. So our mission, or any machine tool builder's mission, is that going to reduce this 5 million machines to 1 million. Okay? By doing this, we can reduce the number of the operators. Or maybe we need more sophisticated programmers for MX technologies. We can, spindle motor is reduced and less networking capital. That means we can save the energy. And also networking capital is going to be reduced because of the work in progress is going to be reduced. Very, very good for things. One problem, we have to make a new 1 million machine tools with MX technologies. Our capacity, or we are 3.5 billion US dollars company with 4,500 machines. And we have about 20-25% market share for MX adequate machines. So global capacity is something around 20,000 machines. In order to make 1 million machines, takes 50 years. So the original MX machines becoming after 50 years old, 50. So there is a very, very, the never-ending stories, very long strategies. So some people say that we don't need so many machines. Oh, you are crazy. You are a manufacturer. You have to make more. But I say, no, we're just going to make this. This is, we have to change the rule of the games, but the huge opportunities. So I strongly believe that the U.S. going to bring back more manufacturing to this homeland, but in this case, that we don't bring the old technology from Asia. Just bring the new one and going to make some revolutions in the manufacturing. So what we are now applying or already commercially available from our company is that digital tooling. Tooling is, not so much selection of the good machine tools, DMG MORI or Mazak or Okuma, Makino or Hans or Hera or Index, Trav, Hamre, Matsura, Nakamura. So you can have about 10 to 20 selections. But toolings, it's like wines. So you can choose from California, or you can choose from Spain, or all over the world making the wines. So if we are running the French or Italian restaurant, you have a lot of confusions, how to select wines. Same as tools, so too many varieties. But by using some of the digital technologies, AI, we are working very hard together with some of the top-notch tooling companies going to make some AI recommendations based on our cutting know-how and so on. Green mode is also, it is becoming very famous. People are using a lot of high-pressure coolant. But if you think about the fluid dynamics, this thin tube, and you understand the gravity of the fluid. So that is, there is the limit. You can pass the quantity of the fluid into the thin channels. But we are pushing. We need more 80 power, 120 power. Just generate the heat and consume the unnecessary power. So by use of the AI and digital twins, we can make the most smooth and the perfect way of the handling and controlling the motors and the liquid, those kind of things. Also, thanks to, we need a little bit more securities. Machine tools, 1/3 of the value of the machine tools or manufacturing system is a mechanical things. 1/3 of the value is electrical things. And 1/3 of value is the software. And as a Tesla or any other sophisticated computer systems, we have to rewrite or upgrade the software every 3 months, 6 months, or something like that. You know what happens at iPhones, So we want to do the same things for machine tools, We want to be perfect for the software side, but always customer try to use the very tough way of using the software. And we found out some of the bugs or improvement points. So we want to do that. But today, we have to dispatch a special service engineer with a special computer to upgrade your software on the machine tools. If we could have a very secured connectivities with a 5G or latest Wi-Fi from the cloud, we can do this very autonomous way for upgrading the machines. So, and also monitoring type of things and integration, those kind of things. Huge opportunity for us the security is very important, but I strongly believe that the US military sections and the government sections will define some of the security measures for connectivities and so on. The governmental guidance for those kind of things is very, very important. Think about all the internet started with a military system, or original, the MIT in 1950s, original CNC machines are supported by DARPA of the US government foundation. So those kind of security is keenly needed. Okay. Well, this is just a commercial thing. We have a largest machine tool show in Hanover. If you have a chance to come to Hanover next week, please visit us. Well, We originally have a big booth in the IMTS Chicago show, but we quit it because Chicago show is so popular. So we have the same booth with all other competitors, and we cannot show our entire philosophy of the world. In case of IMO show, because of the fairground is so huge, so we could occupy the entire hall number 2, maybe too large for us, but in order to keep the reputation and the customer's expectation that we keep the entire hall and showing our world. We can show the 40 machines and the connected and showing all the digital type of things and the peripherals and so on and so on. We are very much happy implementing the digital twin test card with this. We have, as a machine tool data company, we have all the data of the machines, and we have the CAM data working together with a Mastercam or Esprit or NX and so on. And the workpiece, customer brings the data and the materials to our cutting research center. And we work tools with a special tool company from Germany or American Keynote or very nice small to large companies. And with a digital twin test card and doing the real test card and doing a lot. We have been doing this every month about 100 to 150 digital twin test card and the real test card. They're becoming more and more intelligent. Okay, and the next one. So in order to make it more speedy, at this moment we are using Fugaku. Maybe you are not familiar, but up until 2 years ago, this is the fastest supercomputer in the world. Now becoming number 3, something like that. But I'm very excited that this state of Illinois may make some huge investment for the quantum computer. Then we want to be a partial user for that. You can see the complete difference. Normal workstation, typical big dies for the Tesla or Toyota motor cars, the bodies, takes real process 8 hours, but to make a very precise test cut on normal workstations in a digital twin takes almost 60 hours. Then that with this supercomputer, it's 0.2 hours, and maybe quantum computing only 1 second, 2 seconds, or something like that. So the productivity of the digital twins becoming much, much more faster, productive. Very exciting. So next one, please. Also, this is MIT based startups. Mr. Nathan Linda is the president, and we are the 15% shareholder of this Tulip company. And I think that some of the members are already using this. We are using around this low-code digital manual or data gathering system in our shop floor, especially for the assembly shop floor, more than 1,200 stations all over the world. I can give you some of the moving pictures here.
There are varieties of shop issues that block productivity improvements.
Still, many shops using
Tulip
paperwork.
tackles those problems and provides full support to ensure efficient production through shop digitization. Some of you may be hesitant to adopt digitization because of the negative image that the preparation and management are too complex. Tulip is the optimal solution for such shop owners. It supports your shop digitization in a simple and smart manner. The installation is also very easy, so no special equipment or change to the current shop environment is necessary. You can create operation instructions as well as various applications with no special programming knowledge. The contents can be changed flexibly. The applications can be deployed to production sites immediately via the cloud. As the information is shared in a timely manner, it enables you to promptly respond.
So you will have a demonstration in these types. Also, we already connected about 10,000 machines in Japan, the US, and Germany for monitoring 24 hours, 365 days. And then in our case, we call it a condition agent. This is a preventive maintenance or prediction systems for the failure of the machines. We're already quite confident that for the spindle or ball screw type of the failures, 100% we can detect about 1 week to 2 weeks before the failure. Thanks to today's cloud systems and also very high power computing systems, and also nice sensors over there. We need more securities here, but by doing this, the problem over the world, as I said, that 5 million machine tools, average usage of the machines are just only about 1,000 hours a year, or 1,500 hours. Theoretically, or most profitable machine shops, factories are running the machine at least 20 hours a day and 300 days. So that means 6,000 hours. Well, we don't have to run 6,000 hours, but if you are properly running the machines at least 3,000 hours, 4,000 hours, you can run the machines, and then your cost per seconds and minutes are becoming much more cheaper. Even you buy very expensive machines from us, but I'm quite confident. So our mission is that to keep running the machines as long as possible without a major breakage or stop, and also keep running the machines more longer, day and night and weekend, and also even the vacation time by use of the automations. So DMFS, U.S. government business, Navy, and Department of Energy, and Army and Air Force, and national laboratories such as Oak Ridge or Lawrence is very, very important for us. Unfortunately, we are Japanese and German manufacturer, so I cannot be a U.S. citizen because if I move the citizenship to here, I have to pay a huge tax for the Japanese government, vice versa. So anyhow, but very close relationship with the 3 countries. So we decided with Mr. Jim Nudo and Mr. Mark Moore, the 4th generation American citizens, and with all clearance and so on, we created a company, special purpose company, working together with those kind of governmental divisions. And this is quite successfully growing. We know how to prepare all the documentations and how to secure all the digital connectivities and so on. Also, I'm very proud, as a machine tool or mechanical company, we are having the special purpose ITAR certified factory in Japan, in our factories. And then we already started with several projects. By doing so, of course, we have only 1,000 people in the United States, so the number of the application engineers sometimes filled up. So we can use Japanese security clearance engineer to support the U.S. ITAR-related customers to do a test cut and the manufacturing, those kind of things. Yep. Okay. And thank you very much. This is the end of my presentation, but very happy to work together with MxD and your colleagues. And if you have a chance to come to Japan, don't hesitate to contact us or to Germany. Thank you very much.
We're not going to let Dr. Mori run away too soon. So actually, we collected some questions from different members that we asked ahead of time. So we're going to let the stage get reset up, and then Dr. Mori will come up and we'll facilitate a couple of questions before we head out for our break. So the first question I want to ask is, like, we spoke about the workforce. So last time when we were having dinner, we talked about the need to bring more people into the workforce. You spoke about it today. So at your Hoffman Estates facility, you have the DMG MORI Academy.
Yes.
Can you talk a little more about that, but also share your thoughts about what do we need to do to make sure that we have the right workforce for manufacturing?
Well, we have an academy, or in other words, it is mandatory, or we have to create more new machine tool operators or programming people who understand the 5-axis mutants or cutting phenomenons, and also CAD/CAM technologies and robotics teaching and those kind of things. And in case of Japan, we are still hiring the fresh graduates from the technical school, high school or college or universities, and give them about 6 months to 2 years training as employees. And also in Germany, we have apprentice programs in high school age people joining the company, and 2 years, and they can choose the company, but we also can make a long-term interview with them. So we're just going to make something good, pick up the good points in the Japanese education system and the German training system, and bring coming to the United States with the US flavors. And targeting for since it's a Hoffman Estate, so students, the younger generation coming from the local schools, and also some of the ex-military peoples and coming back to citizen life, that we are supporting them to be a real manufacturing person engineers.
Yeah. You mentioned last night that you want to give them the skills that are the higher pay, higher value,
Yes.
not just manual labor.
It is very important, of course. Well, if we compare with the current exchanging rate, U.S. salary system is one of the highest in Europe, same as Switzerland. So with the same skill, application engineer or service engineer. But I also simultaneously know that the living cost in the United States is way too expensive compared to other areas. So that is proper. But if we can create those kind of people who can do programmings and the robotics and the machines and the selection of the tools, and the age of the 40, if we can give them a 100K to 150K type of things, middle or upper middle class type of pips, we can recreate the manufacture, or not recreate, it's already there. Some of the very advanced machine shops in the United States are super good, even compared to Switzerland or Germany. But we can increase the number of those kind of, or make the existing machine shop more greater.
More successful. Oh, thank you. You talked about like AI and other things, but what technology excites you the most that's starting to impact manufacturing?
Well, one thing is that the connectivity and the monitoring or simulation systems are exciting me a lot. And the other thing is by doing the more research and selling the products in the additive field, we mechanical engineer or electrical engineer tend to neglect the power of the materials. So we learn more and more the importance of the materials, not only castings, but also the many exotic materials can be used on the machines, even including the high advanced plastic type of things. And also the advancement of the biological nature-based designs, topology type of designs, and we have a power to create the topology designs to realize by use of a SLM or DD type of things, and we can use it for the mechanical components. For instance, I ask my engineer, that becomes our corporate rules. If they are going to make new machines, they have to use at least 3 additive-made products, parts into our machines. So this makes us very, very exciting for making something new.
Does that force you to use your own machines, to design your own machines?
Yes.
Eat your own dog food is how we call it in the States. Let me ask you off the question. So you spoke about quantum. We talked about quantum last night. We host a quantum event here every year. When do you think quantum will start to actually show up in manufacturing?
Well, first, some big company like IBM or Microsoft or whatever, they have to make some reliable case, computer. But as soon as they are making such kind of things that real application is there.
Yeah. Well, the simulation one is really interesting because it's so fast that you could do real-time simulation like constantly.
We need more simulation, especially for cutting phenomenons or additive phenomenons. You see that about in case of SLM type of things, you have a powder bed, and there is a 50 microns, 100 microns powders, very different shape, and shooting the laser, depending on the power that like accumulate.
Yeah.
So we have to simulate those kind of things
To predict it.
Yeah. So today's computer, today's our algorithms cannot
Do it fast enough. Yeah, unless you have a supercomputer in your backyard.
Well, we are not so.
Most do not have.
Yeah.
For those that don't know, if you get onto the factory floor, DMG MORI is demonstrating their mobile factory. So it's basically shipping containers, and collectively it's additive, subtractive. There's also a little office in a shipping container. So it's a wonderful combination of demonstrating it. Could you talk a little more about the vision of that?
There's a demand for the remote area, maybe the battlefield, but most of the case, especially from energy-related industries in the platform in the North Sea or Gulf of America or US or something, and then they ask us to make the repair factories for those kind of things. Maybe in the future, some people are starting to ask us, they want to make some of the manufacturing facility in the moon, on the moon. So those kind of remote areas. Also, machine tools are still very big compared to the size of the real workpiece. So that means that gives us some kind of chashitsu. Chashitsu means that there is a tea ceremony in Japan. We do a tea ceremony in a very, very small rooms. Yeah. Only 3-4 tatamis. So that gives us a more compacted ideas to make machine more efficient. Yeah.
Never would have connected machining to tea ceremony.
But for me, it's
yeah. Different thing. Actually, I was surprised to hear part of the inspiration for doing this was you used to put your machines on trucks and you would drive them around Japan to demonstrate. So they had to learn how to basically make a machine mobile. But the concept also is that you could start with the shipping container and then remove the container once you built your factory and you keep the machining. Yeah, so it's thinking to the future of manufacturing. Is there anything in the last couple of minutes that you want to share with the audience or that you want to ask the audience?
Well, we are now trying to, not yet there, but by connectivities, we can predict the failure of the machines in advance. Yeah. And it's always chicken and egg type of things. If we can connect our machines more safely, you are keeping your money in the bank or security companies for your stocks and so on. And nobody wondering about that. Yeah. Why only machine tools cannot be connected? Yeah. So maybe we have to increase our trust by a customer more. But anyhow, by doing so, we can give more advanced guarantee, not in 1 year, 2 years, but maybe we can offer. Of course, we have to make more robust machines, but or have to fight against swabs or chips and the coolant. But 5 years warranty or 10 years warranty, something like that. Then we can combine our offerings with a financial package. We can guarantee by payment. You pay this for next 5 years, 10 years. We guarantee your usage uptime. Then you can calculate your machining cost by yourself. This is my dream.
The thing too, because we were talking about this at dinner last night, there's an inherent piece that the factory actually has to have access to the internet. It has to be secure. But you raise an interesting point. Like, it's not just technology. Maybe government policy can encourage
policy.
that. Yeah.
It's a highway with so many gangs. So we just need more police type of things. Of course, we need the freedom of the ideas, but we need some very strict rules, and that can be only achieved with the government.
Well, at MxD, we're really excited to have you in our facility because we have 5G networks, we have physical networks, we have technology partners. Hopefully we can show this future in practice here working together. So it's Dr. Mori's birthday today. So not only, so we are so thankful that you were able to speak, not just to speak with us, but also share your birthday with us. So thank you so much, and let's give Dr. Mori a last round of applause.
Thank you.
Thank you.